Hello and welcome everyone. My name is Alper Mermer. I'm working for ThoughtWorks UK. I'm originally as a QA, of course. Originally, I'm from Turkey, and as a nice trivia, my great-grandparents all come from Kırım, Ukraine, so it's kind of feels like home. Unfortunately, I don't have time to visit Kırım, but sometime I will. Anyways, today I'm going to talk to you about microservices and what the testing aspects are for microservices. Just to set the expectations right, I'm not going to dive deep into the technical details of microservices. I'm just going to visit the touch points with testing, and I'm not going to give a great description of what needs to be happening in order to say a system is using a microservices architecture. This is my own experience. This is my own takings from this architecture. So a lot of the things you might hear might be my opinion. So please keep that in mind. Second, in the coming few slides, I'm going to go over the terms that I'm going to be using. Again, those terms can mean different things between different people. So I would just like to make clear what I'm talking about when I say a unit test or an integration test. So before going into detail, let's have a look at what topics we're going to cover. First of all, microservices means that services are built and deployed independently. So we are going to have a look what that means in a testing perspective. Second, a single microservice would not make too much sense if you are building an application. So they need to talk to each other, and we see how we manage that in an independent environment where all the services are kind of free. And then we're going to see how we are going to manage an automated build system, an automated procedure that you have to reach a level of maturity, be it in continuous delivery or continuous deployment. So that's what we're going to look. And then data. Data is very important when you are testing something, and we will see what is different in a microservices environment in terms of data. Cross-functionals. Now, cross-functionals is the term that we use in ThoughtWorks in place for non-functionals, just because the term non-functional doesn't make too much sense to me, actually, because everything is functional. Everything has an impact on the functions that we implement, so we call them cross-functionals. And they have to be tested way before, because we don't have a complete system in our hands. And then we have to find ways to execute tests way earlier before having a complete, fully functional environment. So we're going to have a look at that. And finally, contradictorily, we are going to have a look how we can execute tests far later than the deployment itself. Right. So again, as I said, before going into what we are going to talk about, let me clear the ground for the terms. Now, did everybody hear about this famous test automation pyramid? Okay, we are all sick of it, aren't we? I actually think this is a simplistic view. The test automation or test pyramid does not define things very well, but I'm going to use them as a reference point. So here we go. Now, this one, okay, this one we call an anti-pattern, which means that it shouldn't be there. We should do things, and we should refactor things to get away from this, which was basically the first stages of our test automation. What we had was we had a huge cloud, we had a huge effort of manual exploratory testing, which was done by hand by QAs or testers, and that was huge. Like, that was the part where we said that, okay, we trust our system. And then below that, we have a huge automated GUI tests. Again, it's kind of odd to be speaking in a Selenium conference and bashing the GUI-based tests, but I'm going to do it anyways. So we are never going to say that we don't need any end-to-end GUI tests, but what we are going to say is that we have to limit the number, and we have to try to distance ourselves for a fully detailed GUI-based automation suite. We had them, they run for, I don't know, a few hours, in days in some cases. Believe me, I have seen some projects where all the GUI-based automation tests were taking days to run. And below that, we have a few number of service or API or acceptance tests. We had our services to a level. We had automated them, but they weren't covering too much functionality. And down below, we had the unit tests. I don't know how many developers we have here. Could I see a hand? Wow. This is actually the first conference or first speech I'm doing, which the devs are the minority. So I'm more free to bash devs. All right. I'm a developer myself, so don't get confused. Unit tests were not written in a manner that we wanted them to be. There were some, but they were not comprehensive. They didn't have too much coverage. They didn't test all the functionality. And again, people saw that, developers saw that as a chore. They didn't want to do it. They didn't believe in doing it. So what we had was we write our code as devs, and then testers or QAs test that code. I write, you test. We are trying to get away from that approach now. That's why we didn't have too many unit tests back at the time. And on the right side, we see a kind of an ideal test automation pyramid. So what we have, now this time I'm going to start from the bottom. At the bottom layer, we have the unit tests. The pyramid is trying to explain that this layer has the most area, and this layer has the most number of tests that are run. That covers the most functionality that we have, and they are very fast to run. Unit tests are very fast to run, or at least they have to be. And we cover most of our functionality there. They are owned by the devs. So how many people are there is practicing or involved in practicing TDD? OK. So this is what we have to work about. We have to propagate the TDD style. We have to see the benefits of it. Now, in TDD, you have to think of the design before going into the tests. Or, sorry, before going into the production code. So what we do is we write the test, we see the tests fail, and then we write some code to make those tests pass, and then we refactor it. Red, green, refactor. So that's the most of the testing that we do, or we strive to do these days. And then up on that, we have our service layer tests. These can be component tests, which are testing the functionality as a small unit, not unit, small component. Components can be consisting of several units. And then you have your integration tests, which, again, integration test is the blurry one that I was talking about. So it can differ what people call a unit test, what people call an integration test. I'm going to explain that. And then we had our service tests, which run as a service, which had a lot of functionality, which was provided to the customers, but they didn't have any GUI in them, and they were fast. And on top of that, we had our automated GUI tests. We are never, actually, I don't believe we will ever get rid of automated GUI tests, because you have to make sure that things are working perfectly in a fit. The way of doing it is limit their coverage, see if they are touching the critical paths, and that's it. You have tested most of the edge cases, I mean, almost all of the edge cases and most of the functionality down below. You should have written unit tests or integration level tests or acceptance service tests, whatever. You have to limit your GUI-based tests because they are expensive to run, they take a lot of time, they need a browser to be up, whatever, and they are kind of, well, it's not very hard to maintain if you write them properly, but in most cases we see them being very hardly maintained tests. And then, of course, above all that, on top of that, we still have our manual exploratory sessions. Now, I'm going to be honest with you. I have worked as a tester at QA all of my life, all my professional life, and the most gain that I have had from a testing session was in exploratory testing. That is where you find most of the bugs, not most of the bugs, most of the critical bugs, most of the important bugs, and most of the bugs that users would actually find. So although it is kind of a blocker, you still have to have that, because all the things that you have been building here are there to make sure that you have covered most of the functionality you have. You have covered most of the things that you can think of before going into the product itself, which is deterministic and which is great to have, and it gives us a lot of freedom, a lot of time to do the actual tricky stuff up in exploratory testing. So they are still very important. And again, the owner part. Now, this acceptance integration component tests are co-owned by the devs and the QAs. So most of the time, devs would be going to write those automation tests, but pairing with QAs. So QAs are the people who should be taking care of all the big picture or aware of the big picture and see what's going on. So it would be greatly beneficial for them to pair with devs at that time. And automated GUI tests are solely owned by QAs, in my experience, which I see being benefiting more, because they actually describe the behavior that's going to happen in production in users. So it is best that some testing mindset is involved in writing those. And then, of course, manual and exploratory testing is us, QAs. Right. Let me show you a small service integral things, what I call WATs. So what we have is component 1, component 2. These can be one class or a few classes that are working in tandem. Now, inner workings of that class is a unit test, obviously. What I call here is, some people call this integration tests. If two components are talking to each other, but they are still in the same domain of the service, I still call it a unit test, because that is what describes behavior other than the integration itself. So you will need to touch some functionality in that service in order to have a test coverage functionally. So you can't do it, you can't say this is an external thing, this is an integral thing. That's why I call them unit tests. And then if our service is integrating with, well, they would have to integrate with something, a data source or a message queue, I would call that an integration test, because that is where you start to have a look at a different tool, a different framework for your data. So I call them an integration test. And then one level above, now we had our service here, our integral parts here. We have a few services talking to each other in a microservices environment. So what we have is a consumer-driven contract test, which I'm going to explain. And then contract tests. A contract test is a test where you write for an external service, a completely independent service that you have and you need for your system. It can be something, for example, in a banking project, let's say. It can be something different a credit card company provides, for example. Or something if you're in a, how should I say that, government operations, something, for example, of the citizen database, something external, something that you don't build and deploy. You write contract tests for that external service in order to say, okay, this service is working correctly as I expect it to do. And then we have this acceptance or service tests around our service, which test the functionality of that service alone. And then, circling all the GUI and different services are journey tests, which I'm going to talk again. These journey tests are generally GUI-based. They can be just services if you are working in a backend environment and you don't have too many GUIs. But generally, if you have a GUI, you would write some journey tests around that. Right. OK, our first topic. Services are built and deployed independently. So that's the basic thing of microservices, right? You have many moving parts that do something which makes sense, which are little parts of the functionality that you want to implement, but they are independent. I mean, we want them to be independent because we want to have a system where we can deploy bits and pieces easily, and we want to put in pieces that if one fails, the others will still continue working, or at least would not crash. For example, if your login system is not working, your login service is not working, you should still be able to open a page and say that, OK, we cannot log in the user at the moment, but we can still show you our products, our history, our contact information, whatnot. So you can't depend on other services to be up. You have to build in some measures to avoid that dependency. We use, this is a nice picture, actually. I mean, I found it. You have to use test doubles. A test double can be a mock. It can be a stub. It can be something more complicated. It can be something more intricate. But you should be able to write some test doubles. Imagine a service, let's say a login service, let's say. You are depending on a service called customer information, right? Your customers are going to log into your system. You are the login system itself. You take care of the passwords, usernames, whatever. But you are expecting some information from the customer system because you don't know if someone is logging in, if they are a real customer or not. So what you have to do is either have that customer service always up, or you can mock that customer service. There's a great tool that a fellow thought worker has written, Mountebank. It is primarily written in Ruby, but it has been ported to many languages now. So in that Mountebank server, you can write up test doubles yourself before going into the functionality of your own system. You can say, for example, if I hit this endpoint with these parameters, I should expect some result, this result. You can write them very simply. You can write them as a stub, saying that if I hit this endpoint, I will always get this data. You can give them functionality. You can say, if I hit this service as such, I should have got a response in a different manner or some link to a different thing. So it's a very useful tool that you can build the system around your service, which will act as the real system itself. And then you have to be able to run all those tests that you have written in isolation. So you shouldn't be, again, depending on other tests to be up, other services to be up. You have written a mock server, and you have to be able to run it independently. So what we do generally is, if we are writing a service, we create, let's say, a Docker image. We run that Docker image up. That Docker image would contain some service doubles, which will act as the integrated system that we are building. And those tests are run without depending to a different system, which will have these frameworks installed, these language packs, these SDKs. So it's very easy to pull them up, run them, see the results, and destroy them. You have to be able to do that, to have an isolated testing environment without having an integrated full testing environment. And then, because services don't make sense by themselves, you have to put in ways to ensure they are communicating correctly. Because let's say you have an integrated system, a Docker image that you have fired up with a Mountebank server. You think that your service is doing the correct thing with the service doubles that you have, test doubles that you have written, but what if the other system has changed? What are you going to do? I mean, you have written something which works on your machine or which works on your Docker image, but it doesn't work with the real thing. How do you solve that problem? There's this thing called consumer-driven contract tests and contract tests. What is a consumer-driven contract test is this. You have two services. Again, let's come back to login and customer service, right? Let's say that login service is expecting customer service to return the user ID, email, username, and user surname. Yeah? You are putting in some tests saying that, OK, now the customer service is the provider. It provides the data. The login service, me, I am the consumer. So as a consumer, I write a few tests saying that, OK, I want 4 fields from you. Field names would be this. And fields should be, for example, for name, 50 characters, only chars, and nothing else. You write those tests, and then you give those tests to the other service. The other service takes those tests, puts them into their own continuous delivery pipeline and see if those tests are failing. They know one of their consumers are not going to be happy. One of the other services that consume that data is not going to work. So they know what they have to fix, and they know the contract between two services. So a tool called PACT, which again is ported into many languages. At our current project, we use it for Java, but you can use it for Ruby, whatever, C#. So PACT helps you write and maintain those consumer-driven contract tests. So have a look at it. It is, I wouldn't go into too much detail, but it gives you a quite nice environment where you can set up and use those CDC contract tests. And again, the difference between a CDC and a contract test is this. Like, if you are writing a contract test, you are writing it for yourself. You are not giving it to the provider, because the provider is out of your company. You don't have access to their code. They wouldn't accept that test. So what you do is you write a contract test saying that, for example, this external citizen information system is going to provide me, I don't know, with a national ID, name, address details, whatever. So you write that test for yourself, and you see if they are breaking. For example, that citizenship information has a new version, which uses a complete different communication style that you had previously. So you have to see and fix what the problem is. Because we are automating things now, because we have services which are built automatically, tested automatically, deployed automatically, we don't have that lead time between deployments, right? In the previous world, what we did was we planned things, we developed them, we tested them, and then deployed them. And these had long distances between them. For example, you would start testing something, you would spend a few weeks on testing it, and then the developers would only be bug fixing. And once you were finished testing, you would have some lead time to have the new deployment and test it again. At the moment, we don't have that. In an ideal environment, what we strive to get is have tens of deployments every day. In order to do that, you have to automate things. You have to put layers of testing and layers of deployment. So multiple layers of testing is what I was talking about when I showed you the testing pyramid. Testing does not start at the end. Testing does not start once you have a complete functional application. You have to put in tests before going there. So there should be a layered path to production. You shouldn't be saying, OK, we have a dev environment, we have done our developments, and then we have our test environment, we test things, and if everything is OK, go to production. You can't do that configuration manually. You can't do that because you have microservices now, and you don't know which one of the microservices is going to be deployed next. You have to put in a layered approach to your production. For example, generally what we have in projects is development is basically done on either local machines or images that don't actually live as an integrated environment. And then once we commit our code as devs, or when our devs commit their code, a lot of unit tests run, integration tests run, CDCs run, journey tests run, and if everything is OK, we have a green deployment, we then deploy it into our test environment. On that test environment, we see if there is any more automation that we need. For example, we might want to automate our cross-functionals. We run our automated cross-functional tests there, and once we are confident in that, what I call generally a QA environment is we deploy that clean thing, which has been rigorously tested automatically, and then put it into a clean environment. In that clean environment, we do, as testers, our exploratory testing. See if something is going on. See if it is ready to be deployed to a staging environment. And how we deploy it to production has a few ways. Let me put both of them. Now, first one we use is, for example, blue-green deployments, and canary releases is the second one. Now, the difference between them is, in a blue-green deployment environment, you have all your automated tests somewhere, you run them, you do your exploratory testing and say, OK, this thing is ready to go to production. So you deploy it into a blue environment, and then you switch your traffic completely from green to blue and see if everything is going OK. If things are going to be integrated well, users are like using it without any major problems, you switch everything to that blue environment, and that blue environment becomes your green environment. Green environment is where you store your latest production code. And then canary releases are the releases where you, for example, deploy your production code, again, to a different system, let's say as X environment. You divert your traffic, for example, 5% or 10% of your traffic to that environment and see if things are going well. If things are going well in that 5%, 10%, you increase the percentage of that canary release. 10, 20, 50, 75. When it gets 100, that again becomes your production. So you increment the number of users which uses the new production environment. You see, I've been referring to a lot of environments as like dev, test, blue, greens, staging, whatever. You have to put in means to make that environment repeatable, and which share the same configuration, same instructions to build, same way of deploying them. So you can't really be doing a manual operation here. You shouldn't be saying, OK, now I'll give this code base to our ops people, and they're going to put this through various environments, and they're going to do the necessary configurations. That really doesn't make sense in an automated environment, because you should be able to version your things, version your deployment scripts, version your data configuration scripts, everything. They have to live as code. There's a great book that I'm going to suggest to you called Infrastructure as Code, written by Keith Morris. So please go and read that book. It gives you a lot of insights about how to do this. Again, you can be using a lot of things here, like Vagrant, Ansible scripts, Chefs, Puppet scripts, Docker, a lot of things to enable that. Right. Now, we have touched on how functionally we do these things, and there's a trick that we have in microservices. Now, again, in the previous world, we had the single source of data that we always visit, a database, a relational database, that every data the system uses lives. At the moment, we don't have that. Because our microservices are autonomous, they should be managing their own data, and they should be able to not touch anybody else's data. They should be responsible for their data only. They have to be managing these separately, and they have to create their own data one by one. And how to do that? Now, I know we have a lot of scripts to create our data, but there are some tricks how to do that. Each test has to create only their data and only the data that they are going to use. Because we are, let me put that up as well, and also they delete that data only by themselves. And the reason for this is, in the old world, what we had was we had this database, let's say, testing database. For our automation suite to run, we deleted all the old data there, and then we run some scripts to build these schemas or tables that we needed. And then we ran another script which would insert all the data our tests are going to need. And then once the tests are completed, we were sure that it was working with our own data. Now, because we have time constraints and we want to have a fast feedback loop, we have to be able to parallelize things. Once you have parallel tests, which are testing the same application, same microservice, but are fired up at the same time, you can't be creating all the data at once, and you can't be deleting all the data at the same time. Because if you do that, the other tests which are running in parallel is going to fail. So what you should do is, your system should create some data, your one test should create some data, and that data should be known. your test should somehow be aware that I have created this data, and at the end of that test, it should delete only that data, so that other parts of the system are still enabled to work without any interference. That actually is one of the things we spend a lot of time on. Once you get that, once you put in a nice data creation and deletion system, actually functional testing becomes much easier. So, I have been talking about a lot of layers of tests now. Unfortunately, I say unfortunately because having a monolith system has its comfort zones as well. You know what you are going to test. They make a lot of intuition. They are intuitive. And you actually can determine what you are going to do as one thing, and it's easier. But you don't have that luxury anymore. You have little bits and pieces of code working independently, and you have to find ways to test them. And you can't do it at the end. You have to start before things get complicated. So there are cross-functionals that you have to take care of. Like, you can't be saying that, OK, I will write hundreds of microservices, I will integrate them, and at the end, I'll have a look at their performance metrics. How performant are they? Are they taking like 1 second to run, or are they taking, as a system, minutes to run? Now, if you do that at the end, you will soon face the fact that if you want to change like a central piece of architecture or infrastructure, you have to do it for a lot of services. So you shouldn't be seeing these problems, these issues at the end. You should be able to put in some means of performance tests per area service and run them. And at the end, once you are confident with all other services, you should still be running a complete performance suite to see how much your journeys take time. JMeter, I'm sure that you are all familiar with. Gatling is a nice tool that we have been using lately, which is very performant and which produces very nice reports. Locus is another one, which is, again, very comfortable to do it, but reporting is not as that good. So, other than the performance, we have the security issues now. Now, I'm not going to be ignorant and say that once you have put in some automated security checks, your system is performing great. You don't need any more security testing. I won't say that. What we are doing here with our automated security testing is just catch the very obvious little bits that you might see. For example, is there a SQL injection in the system? Is there a vulnerability of cross-browser XSS? So these are the little bits that we have been testing with our automated tools. Now, ZAP is a great tool that you can direct your application and see what security vulnerabilities are there. Dependency check is good to see the components that you have been using. We basically use most of the time open source components. What security issues your components have. And then W3AF is, again, a nice framework to have those automated security checks. So because we have started to test things earlier, really, the testers cannot be the sole source of testing. We have to involve devs. We have to be there to write unit tests with them, not write unit tests with them, pair with them while they write unit tests and suggest things to them. We have to start much earlier. It even starts from the story review itself. Because we are working with stories now, it's very good to have some QAs review your stories or be involved in the story creation process so that your stories make sense. It is very important. And you will still do some end-to-end tests, but you will have to limit those things. You will have to limit your end-to-end full coverage tests so that you enable a lot of bits and pieces to be tested before. Journey tests are very, how should I say, beneficial in most of the projects that I have been in. A journey test can be considered as an upper set of smoke tests. They do consist the smoke tests. You see that all the components, all the critical components of your system are up and running. You test the critical paths. You say, OK, with this critical happy path, my users in production can do something. They might, this journey would not cover a lot of edge cases, a lot of, I don't know, extreme cases. They might have some negative cases because they are still a journey, but they do cover the bare minimum that you would expect from a production user to do. And please be picky about what you put in here, because I know bare minimum definition can change between testers, devs, business units. In my experience, for a business unit, a bare minimum is everything. So don't do that. Don't have your journey test testing everything. That's where you use your Selenium, your Capybara test, Sahi, Appium, Calabash, whatever you have. With GUI, testing the functionality, but with a minimum number of paths. You really should not pass the limit of 10 minutes for these journey tests. If your journey tests are taking more than 10 minutes, then maybe you should have a look and see what you can do. Maybe you need more parallelization. Maybe you are doing data handling wrong, so have a look at them. Now, because we have tested a lot of things before, and we have a scaling production environment now, we really can't say that, OK, we have tested a lot of things. We are pretty sure that this is going to work exactly the same in production. That's not true. Your real test is always going to be in production. Your users are going to be your testers. Sorry, OK. Your users are going to be your testers. So you cannot replicate the exact same environment that you have in production in your testing. So you have to see what's going on in production. You have to put in some metrics. OK, I have pressed something wrong. And now, OK. You have to put in some metrics, which I'm going to talk today in the afternoon session. You have to see how these metrics are going, and if you can do something to fix them. If there are problems in production, you should be immediately aware of them. You should be putting in some things indicating you that, OK, something is not right in production. Things started to happen. So you should have this kind of semi-intelligent system that tells you that things are not going good in production, and you should put some measurements and warnings for them. It is very good. I would never, in 5 years ago maybe, I would never expect the term testing in production. We do not test in production, but it is useful to have some level of testing in production as well. They can be smoke tests, they can be health checks, they can be some little paths that might go through and see if the main functionality is there. You can use dummy users and dummy accounts to write those tests so that the actual production system is not affected, that kind of stuff. And please, this is the most important part of our system. As QAs, as testers, it is your responsibility to be aware of the system. You have to be the quality analyst. Now, QA is defined as quality assurance. Quality cannot be assured. Believe me, every system we build as humans is going to fail. Nobody is able to assure the quality of any system. So you have to be the analysts that see through this development cycle and production cycle and say, OK, there are some issues. You must be a guide for all your team and your company to say, we have to take precautions. And there's one quote that I like. The best thing a QA can do is make the team aware of quality. Instead of assuring the quality yourself, or instead of testing the thing yourself all the time, make people aware of things. And that's basic. Oh, no, sorry. Who knows what this is? OK, old people. All right. This is a ghost trap used by Ghostbusters in the original movie. I don't know if they have used it in the latest movie because I simply couldn't watch that movie. This is a ghost trap. Ghostbusters shoot the ghost with their proton packs and then lower them down into the trap. So what are the traps that you should avoid? First, do not use a predefined recipe. I have given you a lot of tools that I have used. I'm not giving you a recipe. I'm not going to say you need this level of journey tests, you need this number of unit tests. That has to come from you and you alone as a team. Your project team has to decide what kind of testing they need according to the situation. Now, being agile is just that. When people give you some recipes around agile, saying that if you are agile, you have to follow this, that is wrong. You have to be able to figure out what you have to do. And build your architecture incrementally. Do not spend several months to try to build your testing architecture beforehand, and then, okay, now I'm ready, let's write our development code. That's not how it works. You have to create things incrementally. And you have to keep them alive. If you want your automated test suite to run for years, as our previous speaker mentioned, you have to write them in a good way, and you have to maintain them. You have to educate people so that they will take care of it. Now, as a consulting company, we go in, we build things, and we want our customers to be living by themselves once we are gone. So you have to educate people on how to use those things. If you build in something and once you are gone, all of them falls to pieces, you haven't done things right. You have to keep them alive. There are 2 books that I would like to suggest. Again, Building Microservices, Designing Fine-Grained Systems by Sam Newman, which is a canon book for microservices. It has a nice 7th chapter for testing. Please do have a look. And, sorry, Infrastructure as Code, again, from keywords I mentioned previously. These 2 will give you a great idea of what you should be testing in microservices environments. Yeah, thank you very much. Any questions? And thank you. This is my email address. You can email me for anything, my Twitter handle. And TestHive, I am the founder of TestHive now in Istanbul and in Manchester. We have been doing bi-weekly meetups. And you can follow us. And you can attend our meeting as well. Questions? Would you like to get a microphone?
For speech. Looking for your example, if you have one provider and a couple of consumers, on which side we have to test to make negative tests?
To make a what test?
Negative tests.
Negative tests. I mean, that again has to be in your internal system, your integral service test.
Yes.
The negative paths would be tested there, because the provider cannot test all the negative paths or the edge cases themselves, because that's not their job. They just run the tests that ensures the communication standard is there. So you should be writing your negative tests.
Okay, thank you.
Okay.
Do I understand right that you have 2 stages of testing? First stage, when you test your services in isolated environment where others services stopped, and the second stage where you said to be aware of data interferation, where you test all together, right? So, okay, so it looks in continuous integration, it looks like 2 tasks, right?
Like at least 2 tests.
Okay.
You can have more layers. What we do is continuous delivery. At the moment, we don't do continuous deployment, because continuous deployment is a process where once you commit something, it goes directly to production. There are companies that do that successfully, but if you have a business risk or if you have to have a reputation consideration, we do continuous delivery. So we do all those things automatically and put in something that we have enough confidence to put to production, which is production ready all the times. But then we still have some integrated tests that we do, for example, explorator testing or end-to-end tests maybe, so that we have a secondary level of defense and check everything is okay to go to production with a 99.9% confidence. So yes, we have multiple layers.
Thank you very much.
You're welcome. Okay, I think we have to stop now. Thank you very much for attending.